Hello everyone, so welcome to the first lecture of week 1 of this course of deep learning for natural language processing. So today we will be starting with the introduction to the course. So I am Pawan Goyal from the Department of Computer Science and Engineering at IIT Kharagpur. So what will we cover in this particular lecture? So we'll talk about the course, we'll give the course information. What is natural language processing? So what is NLP? Why do we need to do deep learning for NLP? And then I'll briefly talk about the course content. So this will be the outline for this lecture. Now I will be the instructor for this course. So this will be my email ID. If anybody wants to contact me, we can use. This is my course page, this is my web page. And we would have a dedicated page for this particular course where you can find all the resources, including all the programming assignments and notebooks that we will create. So you can go to this page and you will find all information relevant to this course. So for this inaugural session, so we will have 2 teaching assistants. So Bindu and Preetam, they are both students at IIT Kharagpur. Now, what is natural language processing? So before I talk about that, let us understand what are natural languages. Right? So natural languages are languages that are typically evolving when humans converse to each other. Right? So they are evolving through human usage. Now this is one chart that you can see from Wikipedia about language families, and at least some you would be familiar with, like here the Dravidian family, here's the Indo-European family, so where most of the other Indian languages typically come under, and you will find a lot of different families across the world, right, across the globe. Now, so we are talking about all of these as the natural languages, right? Now, given this natural languages, what are we typically trying to do? What do we mean by natural language processing? So we can define it briefly as we want to make computers understand what we are writing or speaking, and we also want to make computers write and speak. Right? You can see daily applications that you are using, the way you are interacting with the machines. So many NLP applications typically would fall under these 2 criteria. And what we do in the field of NLP, we try to develop applications. We want to design and implement systems that can process natural languages for various practical applications. Now, what are some of the applications? Now, NLP is everywhere. So let me give you some examples of the applications that you would typically be using. Like on the left hand side, you would see something on machine translation. So where input is given in English language and the system Google Translate is translating into Sanskrit. That is a new functionality that has come in the last year. So your input was welcome to the natural language processing course, and it translated into Sanskrit. Prakritik Bhasha Sansadhana Pathyakrame Swagatam. That was a Sanskrit translation for this English sentence. This is NLP application translating from one language to another. On the right, you can see another application again that is very, very handy. So you would have a lot of emails coming into your mailbox, but some of these may be spams, and you typically don't want to look into all those. So can somebody classify, can a system classify already what is an actual email, what is a spam email? And spam emails will go into spam folders. So once in a while, if you need, you can go to a spam folder and check those. Right? Otherwise, your main emails will go into inbox. That is a classification task. You're classifying emails into spam or not spam. So this is a text classification. Spam, not spam. Right. Now, these are some very, very important and popular applications. Then another application that you would see is question answering. So you're asking this question, who is the tallest living person? And what you see on Google, you would find a lot of interesting information about that person, and a lot of different news from Instagram, CNN, and various places, and brief snippet also comes in, right? So earlier, like I think 5-6 years ago, if you would have typed, it would have given you a list of web pages that are relevant to this question, and you can click on those web pages and get the answer, right? But here now this has evolved so much that it would give you a direct answer, right? And if you want, you can go to various web pages and look for more information. So question answering is another very, very important application. Similarly, we talk about dialogues, right? So on the left, you have an example from persona chat, a dialogue data set where you are given different persona for people and they are conversing with each other. So this is a dialogue system. On the right is just an example on ChatGPT that you are interacting with ChatGPT, right? So with all these large language models, now conversation has become the default mode of interaction. So you can converse with them. They can keep track of your history of conversation and respond accordingly. So they are all both examples of dialogue systems. And then you have auto suggest or auto completion. So this is an example of auto completion. So you are trying to type something. So what should I keep in mind while, and you have written a prefix of filling, and the computer understands what you want to type and it gives you a suggestion, right? You can press tab and accept that suggestion. And this you would find it various places. You can find in your Gmail, in your chat interfaces, and various web pages various AI application would allow this. So this is again an application you can do auto completion. Right? And then I'm coming to a very different kind of application, that is tagging the entities present in the text. This is called named entity recognition. So what is happening? You are given a text and you have to find out what are the interesting named entities, or what are all the named entities present. And you would have a fixed set of tags through which you will tag these words. For example, what kind of tags you are finding? So this is NORP, nationality or religious or political entity, cardinal, geopolitical entity, organization, person. You would have even percent, date. So you have different kind of tags through which you are tagging. It may not be just a single word, maybe even sometimes a whole span. So you have two words, North America, together tagged as location. Right? So this is an identity recognition problem. And again, very, very popular problem in natural language processing. So these are some general application examples. But then if you go to specific domains, you would have very, very specific domain problems, right? So what I'm showing on this slide are problems from 4 different domains. So let's see the first one. This is from customer support domain. So what happens in customer support domain? So you would have various manuals to help you go through various queries about various instruments that you may have, right? So like here is a question: how can I encrypt my SD card? So you want to answer this question: how can I encrypt my SD card? Now how would I get this answer? This answer will be somewhere in the manual, right? So suppose I have a data set of all the various manuals available, right? So given this question, can I find the answer from this data set? So first of all, I need to find out, for example, one possible solution is I find out which section the answer actually lies in. Once I find the section, I would then find the answer in that section, right? I can do it in 2 stages, but there can be many ways of solving this problem. But the task is doing question answering on the e-manuals domain. Right? Similarly, you see something on financial domain. So what is the problem? So you are given a sentence, financial sentence. As of December 31st, 2020, we had cash equivalents of $24.8 million and so on. And what is your task? You want to tag the numericals with a specific tag. Like what does this 24.8 million correspond to? This is cash and cash equivalents. So typically what happens in all these financial reports, you have to have some specific tags for the numericals. And one particular example are the XBRL tags. Right? There may be like thousands of possible tags, and this will give you much more information about what is being talked about in this report. So this is again a problem where you are given a sentence and you have to tag each or the relevant entities with certain tags, right? So this is like an NER problem, right, where these XBRL tags becomes the named entity tags. Now let's go to the legal domain in possible example. So in legal domain you would have like court case proceedings, you may have contracts and so on. So here in this example you are given in contract as input, and the model has to find out various clauses. For example, like some agreements may be very long, like 50-60 pages. Now you want to find out what is the IP agreement written in this, right, and what is the governing law mentioned. So can I simply extract different clauses from this particular contract, right? So this will be an NLP task. And then similarly, if you go to biomedical domain, so you would have problems like name entity recognition again, but now they are biomedical entities, so like finding out disease, genes, proteins, and so on. What is the relation extraction? So you may create various databases like ChemProt and so on. You may do question answering, like BioAsk is one example of biomedical question answering, right? So like what does mTOR stand for? Like this is relation extraction, this is a tagging task. So what we are seeing here, like there are some general NLP problems, and then you go to various domains, you will find a lot of domain specific problems, right? And this will be compounded if you have multiple languages working in tandem, right? You would have a lot of text may be multilingual in nature. So then you have problems where languages, domains interact a lot. Now, given a brief idea about the kind of application, we will go more into that later in this week. Like why is this NLP hard? Like what is so difficult about NLP? Now the main issue, what differentiates natural language from other languages like programming language, is the ambiguity, right? So typically when you speak something, there may be more than one interpretations for the same, right? So this particular you can say meme or cartoon actually explains that one particular example. So the input is, okay sir, next can you tell me a little about your background, right? So this is typically, think about an interview where you are being asked about your background, and that's very general question, like in interviews you give your background. But if you go into that, like the word background has multiple meanings, right? So what is being shown, there are two meanings of the word background, and the first meaning that comes out in this dictionary is the area of scenery behind the main object of contemplation, right? And the second meaning is the circumstances or situation prevailing at a particular time. So typically when we talk about an interview situation, I'll go with the second meaning, right? But I mean that's how you create jokes and you play with these, right? So here for the word background, the first meaning is being taken, and the answer is sure, it's the Mount Everest. That's the background in the Zoom call, right? So this is an example where a word can have multiple meanings, right? And that is ambiguous, right? So this we call as lexical ambiguity, where a word in a sentence may have multiple possible interpretations, and because of that there is an ambiguity in the meaning, right? So yeah, and let's see some more examples, right? On the left you would see again a joke like, would like to buy a muffin with chocolate chips, right? So that's a sentence typically we understand that the chocolate chips are on the muffin, right? But the cashier responds saying, sorry, we only take cash, right? So what does that imply? Like what is the interpretation that the cashier has taken? So it is taking that I would use chocolate chips to buy muffin, right? So just like saying I would like to buy a muffin with my credit card, right? Or so with chocolate chips. So we don't take chocolate chips, we take cash. So again, I mean that's the way you create jokes. So here this is no more the lexical ambiguity. So it's not the same a word having multiple interpretation, it's the sentence having multiple interpretation, and this is an example of syntactic ambiguity, where you can have multiple possible syntax available in a sentence. Similarly, you will see on the right hand side. So please could you go to the shop and get a carton of milk? If they have avocados, get 6. And I mean, yeah, you typically understand the meanings that you get 6 avocados if they have, but like one possible interpretation is that if they have avocados, then get 6 cartons of milk, right? So that's what is the interpretation that is being shown here. So yeah, so that is again an ambiguity. It points to an ambiguity in the language. Uh, let's look at another conversation, right, and then we try to decipher that. So what do we have here? We have Rahul and computer who are interacting. Uh, so Rahul starts by conversation. I saw a monkey with a banana. It's a fairly simple sentence, right? We understand what it means. Now the computer responds back saying that's gruesome, right? But I mean, immediately you would be shocked if you hear this. Like, what's so gruesome about this sentence? That's what Rahul asks. Why? What's so gruesome about seeing a monkey? Right? And now, can you guess what is gruesome about the first sentence that Rahul has mentioned? So hint is that you can go back to either lexical ambiguity or syntactic ambiguity, right? So which one is that? So this one in the first case is a lexical ambiguity. So a word in the first sentence has multiple meanings, and one of the interpretation is gruesome, right? And what is that? So if you see the word saw can be, I mean, it's meant for past tense of the verb see, but it is being taken as saw as cutting, right? So it's like you are using banana as an instrument and cutting the monkey, and that's why it's a very gruesome interpretation. Right? Now Rahul comes back saying, what's so gruesome about seeing a monkey? And it clarifies that in the first sentence, the saw was the past tense of the verb see, right? So it was the past tense of the verb see. So then this interpretation is clear, so there is no more problem. But the computer now responds saying, oh, I see. What else did you see with the banana? I mean, so again, this would not be a typical response that I would do. So why the computer responded like that? What else did you see with the banana? What interpretation it is taking? So it is now taking the syntactic ambiguity. So that is okay. It is assuming that banana is being used as an instrument, right? So I saw a monkey with a banana, as if you used banana as an instrument and trying to see the monkey. So what else did you see along with the monkey, right? So that is what computer is asking. So this is the first one is lexical ambiguity, and second one is a syntactic ambiguity, right? And in natural language, ambiguity is not an exception. It's not that you will only find it somewhere. You can find ambiguities in nearly every possible sentence, like a rule in natural language. But we humans typically are very good at that, and we are typically good at understanding what the other person is conveying, right? But is it also easy for the machines? That's the question. Okay. Now, how do we typically do language processing? So when we do NLP, we talk about various labels of linguistic structure. So we have a sentence here, Alice talked to Bob. Now starting, we can talk about the individual characters that I see in the sentence. So you have all the individual characters that are there, right? But then going ahead, I mean, characters themselves may not be meaningful units. So you want to talk about meaningful units. So you'd say, okay, so they are talking about the morphology, that is, yes, there is a verb talk and there is a past tense, ed. And then you form the words. So talked is a word, right? So you talk about words. So Alice talked to Bob, and then there is a punctuation. So there are 5 words. So once you go to words, next level you go to the part of speech tagging, the syntax. That what are the different parts of a speech? Is it a noun, verb, pronoun? So you say, okay, Alice is a noun, talked is a verb, past tense, to is a preposition, Bob is a noun, and this is a punctuation. And then you can say, okay, how do they connect together? So when I was talking about syntactic ambiguity, I was talking about how different words are connected together in the sentence. So they are connected together to make the meaning. So you say, okay, this is a sentence that is a noun phrase and a verb phrase, right? So what is the noun phrase? Alice is the noun phrase, and talk to Bob is the verb phrase. Again, verb phrase you can see as the verb and a prepositional phrase, that is to Bob, right? And together that makes the sentence, right? This is the syntax. Now you can also do dependency parsing to convey the same idea. And then you go beyond the syntax, you talk about semantics. You can talk about meaning, like what is actually happening in the sentence. So you can say, okay, there is an agent, Alice is an agent, Bob is recipient for that event E, right? And then this event is intemporal, it has already happened, it's happened before, right? And there is some context of the speaker and so on. So you can talk about various other things, right, in labels of linguistic structure. We will talk about some of these in this course, but not too many. Many of these have been covered in the NLP course that I had offered earlier in NPTEL. Now, so given all these problems that we have talked about, like how do we typically solve these problems? What are the different methods that we use? So before deep learning, what we used to do, we typically devise certain paradigms. So we say, okay, we will have certain problems fitting into one paradigm, and we will use methods of that type. For example, if the problem is sentiment analysis, I know I will be given a sentence or a review, and I have to find out its positive, negative, neutral. Or news article grouping, so that is, you are given news articles, say on Google News. You want to say, is it about sports, entertainment, health, right? So in all these problems, you are given a text, and you want to classify into certain classes. So this is a text classification paradigm. Similarly, you have named entity recognition, where you are given a piece of text, but now you don't want to classify the entire text into one category, but you want to say which part of this is an organization, which part of this is a name, person, and so on. So this is a sequence labeling. So you are labeling the entire sequence based on these. And then somewhere you would have to generate text, like machine translation. Your input is one language, and you are generating text in another language, summarization, chatbots. So this is a text generation paradigm. And there are, of course, few more, but they are the main paradigms that we talk about. And we will have methods across various paradigms. Now, coming to what kind of methods that are being used. Now, this is a nice timeline illustrating the kind of methods that have been used from 1950s. So 1950 to 1980 was mainly the era where linguists ruled the field. So where you would have various syntactic and grammatical based rules by which you will try to solve a particular problem. And you had very famous Elijah chatbot and others in that era. Now 1980s to 2000, they were more about general ontology and domain knowledge that was created, and there were a lot of statistical model and n-gram models that were used for, and with some machine learning methods for solving NLP problems. We will talk briefly about n-grams. 2000 onward, the neural models started coming into play in the field of NLP. So you would have like Bengio's famous paper on dense vector representation. Then there were Mikolov's paper and pre-trained word embeddings that started gaining, just their footing in that era, and they become very, very prominent in 2010 to 20 when we had word2vec and glove, other embeddings in 2013-14 when they came. And then after that, it became very easy to use the text input for various deep learning architectures, and that's where you had RNNs, transformers, and other kind of innovations in this time. And then at the end, you also had pre-trained models, so you had BERT, GPT, and others. Right? Now 2020 onwards is the era of LLMs, so large language models. So you have GPT-2, 3, 3.5, GPT-4. So where you had methods like RL with human feedback and various alignments and so on. And now you have a lot of open source LLMs and frameworks that people can use within context learning, prompting, fine tuning, and so on. So, and yeah, we will talk about many of these in this course. Now, coming to this question, like why deep learning is needed for the field of NLP. So this is a very nice example. So distinction between sparse versus dense representation. So before the deep learning era, what used to be done? So we used to use machine learning models, but we have to describe our data using features. Right. So here is an example, like maybe the task may be named entity recognition. So what is important? What are the words involved? So here, what is being talked about? So what is information that you want to encode? The current word is dog, the previous word is the, and the previous part of speech tag is determiner. Right. So this is the information you are encoding. And how are you encoding in the sparse vectors? So you are saying, okay, I'll have 1 and 0s for various features. So this one corresponds to the current word is dog. This one corresponds to the previous word being the, and this one is the pause tag for the previous tag is determiner. So you had individual features, then you had compound features, like this one is the current word is dog and the previous tag is determiner. Right. So this one is current word is dog and previous word is the, and so on. And other features, for example, this is current word is chair and previous tag is determiner is 0 because that is not true for the current context. So you will have a very large feature vector, and that will be sparse. Very few dimensions will be 1, others will be 0, and you would fit it to various models like SVM, logistic regression, and do the NLP tasks. Now what changed with word embeddings was that, okay, why do I have to give this sparse vector? I can give a dense vector input. So if I have to encode the current word is dog, I will feed directly it's a dense vector denoting the word dog, right? If I want to say the previous word is the, I will just use the embedding for the previous word. And if I want to say previous pause tag is determiner, I'll use the embedding for the part of speech tag determiner. So I'll put this, this, and this. This will become my feature vector, and I'll use that for any application. Right there, you can use traditional ML models. You can also use deep learning models, and this was the, I mean, one of the main turning point of the rise in deep learning for NLP. Right? I mean, so you can use this dense representations, and this can help you fit into many different kind of architectures. So just one more point, like the sparse vectors. So there was a lot of effort required in domain knowledge. So you would encode your domain knowledge into your feature vector. But with this dense vector, you can learn them, and then this can be generalized across multiple tasks. Okay. Now, so for example, you can, once you have this embeddings learned, you can use this dense feature representations with various deep learning architectures. Like, so here's an example from recurrent neural networks. So using recurrent neural networks, where you are feeding the input words, Janet will back the will using the embeddings of the words. And then underlying there will be RNN architecture that will take this input and will do its own processing and will try to give you the final output. Like this is the part of speech tag for each word. Okay, but what is crucial are the word embeddings part here. So another timeline visualization of the development. So this is from 2000. So around 2000 we were using bag of words model. What is bag of words? We'll discuss more, but it's more about you have a document, you will just take all the words there without worrying about the positions of the words. So it's like putting all the words in a bag. So this was called a bag of words model. In 2013, when the word2vec came, that was the one of the like very interesting breakthrough, right? Then you had attention model in 2017, transformers, and then you had got the pre-training of transformers. So you had BERT model, GPT model, various GPT-2, GPT-3, and ChatGPT. BERT, you had variation like Roberta, you had a distilled version of BERT, distilled BERT, and you had other things like encoder decoder T5 and instruction tuning FLAN T5 and so on. Okay. So this is how the field has grown. So transformers, so this is the T of ChatGPT, transformers. So pre-training happened with all this BERT and GPT, and you are generating text, that's called the G. So you had the G in the generation. So generative pre-trained transformer was the short, it's what GPT stands for. And this has changed the NLP paradigms also. So earlier we used to talk about classification methods, sequence labeling methods, generation methods. But now with deep learning, what has happened, you can treat every task as a generation task. So this came up in various papers, like T5 paper also showed it, but I have taken this from T0 paper. So where what they are showing, suppose you are doing summarization, that's a generation problem. Sentiment analysis is a classification problem. Question answering can be modeled as generation, and also there are other ways of modeling this. But it said that you can model all these problems as generation. So you give some example of the task. Like summarization, you are saying how would you rephrase that in a few words. It's like a prompt you are giving about the task, and then you create a summary. Similarly, for sentiment analysis, you want to give a scale rating. So you say on a scale of 1 to 5, I would give this A. And you generate what is the rating. So rating is 4. That's what you are generating, right? You're not classifying, you're generating. Question answering. So again, can you tell me what is this? So you say, okay, you give the answer. So you see all the tasks, they say that all different tasks can actually model through generation, and this also helps in generalization. So you can even give examples from new tasks, and it may be able to do. Like this is an inference task where you're given 2 sentences. The banker contacted the professors and the athlete. Can we infer from the sentence that the banker contacted the professors? And the answer should be yes, because this is the inference task. And you can again do it using generation. So this was, again a very nice breakthrough, and you will see that now the generative models can actually do all the different tasks of NLP. They can actually do this via generation. So now, now given this introduction, so let me just talk briefly about what we will cover in this course. So we'll talk about the background. So this week we will talk about introduction to NLP. Next week will be introduction to deep learning and what is representation learning. And the third week will be about word representation. So we'll focus 1 week on talking about word vectors, glove, fast text, etc. and then how do you take it to multiple languages. Then we will go to different models and architectures. We'll talk about recurrent neural networks, RNNs, LSTMs, and so on. We'll talk about attention mechanisms starting from RNNs to transformers, right? So this will be weeks 4 and 5. Then we will talk about different methods like pre-training. So we will talk about Elmo, BERT, GPT, and so on, various pre-trained models. Then we will focus a little bit on tasks. So we'll talk about various applications like question answering, text summarization, dialogues, and we will also give some time on how do you handle domain specific problems and challenges given this background. Then we'll move to some more recent models, particularly large language models. So we will say, okay, so what are the primary methods for building LLMs as chat assistants? So we'll talk about instruction fine tuning, RLHF, various alignment techniques. So we'll talk about how do you typically interact with large language models, like how do you do in context learning, various prompting like chain of thought prompting. We'll also introduce you to various large language models, and we will say how do you actually fine tune them using the parameter efficient fine tuning methods, and in particular we'll focus on LoRa and QLoRa. And then we will talk about some application again from LLMs, like how do you handle long context and how do you also do retrieval augmented generation, by which you can use a much more data set that is even not in the pre-trained corpus of the LLM. Finally, we will conclude the course talking about the analysis and interpretability of whatever we talked about and some ethical consideration. Okay, so yeah, so these are the references for this course. So this would be the main reference, speech and language processing book. So this is the 3rd edition. This is available online. You can search on the web. This is already available. It's actually going on. So this is a very nice and comprehensive book. And there are other books that I mentioned here that you can go through, and this would be very helpful in getting a deeper understanding of the recent topics. Okay, with that, thank you, and I look forward to seeing you in the next lecture.